Hi guys. Okay, question pertama. This one. If 85 gram of NaN3 decomposed at 75 degrees Celsius and 2.3 atm, what volume of N2 will be produced? So 2Na3 is gonna, yang ni adalah equation first, satu benda yang kita kena buat. Sebenarnya soalan ni sampai sini saja. So kita kena create satu equation yang membentuk 2NaN3. So ini adalah equation dia. So bila kita dah buat equation yang pertama, kita cari sebab dia dah bagikan mass untuk NaN3, kita boleh cari dia punya mole of NaN3. So bila nak cari mole 3N2, kita kena cari mole 2Na3 dulu, baru kita boleh nisbahkan dia. Okay, so 2 mol Na3 membentuk 3 mol N2. So 1.3077 mol kita bahagikan dengan 2. Lepas tu akan dapat 0.6529 mol. Lepas tu darabkan dengan 3. Kenapa darab 3? Sebab ni ada 3 mol. Yang ni kenapa bahagi 2? Sebab kita nak cari satu mol tu. 1 mol. Kita nak cari 1 mol dulu. So kita darabkan dengan 3. So kita akan dapat nilai dia 1.9616 mol. So bila kita dah dapat tu, kita boleh carilah volume N2. So N2 ni dia bagi P dia 2.3 atm macam dekat soalan. Lepas tu dia bagi T 75 degree Celsius. Kenapa kena tambahkan 273? Apa-apa pun sebab unit SI bagi temperature is Kelvin. So kita akan tambahkan dia untuk tukar unit. So kita akan dapat 348 Kelvin. And then ni adalah mol yang kita dah cari, 1.9616 mol. So kita nak cari volume dan R adalah constant. So ini adalah equation yang menepati semua yang ada ini. So kita boleh carilah nilai V dia. Sebab P kita dah ada 2.3, V kita boleh cari, N dah ada, R constant, T pun dah ada 348 Kelvin. So V equal to 249. So jawapan untuk V is 24.3672 liter. Itu saja.
Hi, my name is Nur Afika binti Ramli. So, I will explain question 2. The question is, blast furnace give off many unpleasant and unhealthy gases if the total air pressure is 0.99 atm, the partial pressure is 0.99 atm, the partial pressure of carbon dioxide is 0.05 atm, and the partial pressure of hydrogen sulfide is 0.02 atm. What is the partial pressure of remaining air? Again, P total is equal to the total of P component gases, as you have been introduced to Dalton's law of partial pressure. So, this question is a direct question. So, it's already give P total, which is 0.99 atm. So, we consider the total of P component gases is PCO2 plus PH2S plus P other gases. So, here we substitute that we already have, which is 0.99 atm is equal to 0.05 atm plus 0.02 atm plus P other gases. So here we want to know the answer of P other gases, which is the answer is 0.92 atm. So that's all for my explanation. Thank you.
Hi, Assalamualaikum. My name is Nurul Suhada Darwis, metric number CN200118. I'm from group 5. I will answer the question 3. The question is, 10 milliliter of 2 molar as sulfuric acid are needed to neutralize 30 milliliter of potassium hydroxide. So determine the pH of potassium hydroxide. The question were given that the volume and molarity of sulfuric acid. So from here we can get the number of mole sulfuric acid with using this formula. Molarity of sulfuric acid is equal with mole over volume. 2.0 equal with mole divided with 10 over 1000. 10 over 1000 it is because we were given 10 milliliters, so we must convert it to liter. So we will get the value is 0.02 mole of sulfuric acid. Then we write the balance equation of potassium hydroxide and sulfuric acid. So I will get 2 potassium hydroxide plus H2SO4 will produce K2SO4 plus H2O. So we see at the reactant 1 mole of sulfuric acid is equal with 2 mole of potassium hydroxide. So 0.02 mole of sulfuric acid is equal with 2 times 0.02 mole. And we will get 0.04 mole of potassium hydroxide. Next, after we get the number of mole of potassium hydroxide, we can find the molarity of potassium hydroxide using the same formula. Molarity of potassium hydroxide is equal with mole over volume. The mole is 0.04 divided with 30 over 1000, and we will get 1.33 molar of potassium hydroxide. So the next, we write the ion equation of potassium hydroxide. There is K plus OH negative. Then we write the table of molarity in initial, change and final. At initial, potassium hydroxide is 1.23, K plus is 0 and OH negative is 0. At the change, potassium hydroxide we must minus with 1.33, at K plus we plus with 1.33, and OH negative also we plus with 1.33. And the final, potassium hydroxide we will get 0, K plus we will get 1.33, and OH negative we will get 1.32. After we write this table, we can find the POH using this formula, negative log times with OH negative. So negative log, we insert that OH negative just now we get in the table. Negative log times 1.23, and we will get 0.12. And the last step, after we calculate the POH, we write this equation, pH plus POH is equal with 14. So pH plus, we insert that the value of POH, just now we calculate 0.12 is equal with 14. So pH is equal with 14 minus 0.12, and the last answer we will get 13.88 pH of potassium hydroxide. So that's all from me. Thank you.
Hi, my name is Nur Afika binti Ramli. So I will explain in question 4. We have the question is, determine the H3O positive in a 0.050 m solution of BaOH2. We know that BaOH2 is a strong base. So I also will explain why it is a strong base, or we call strong acid. It is because it have more than one H positive or one more than one OH minus is 2 times 2. So it is we call strong base or strong acid. So When it is dissociate, it will dissociate completely. We have base which is BaOH2, so it will dissociate completely to Ba2 positive and 2 moles OH minus. So we are going to the we call the eye diagram. So initially there's no dissociation, so you only have the concentration of BaOH2 which is 0.050 and there's no product, so it will be 0 here and 0 here. So exchange means that it will dissociate. Since it's a strong base, it will dissociate completely, so there will be no longer being the BaOH2, so that's why at exchange we minus 0.050 because there's no more, and then the product of here shall be the same amount. So this one you only have 1, so 0.050 because this one, and then this one because you have 2 mole of OH minus, so it will 2 times 0.050. So final you have no more BaOH2, so 0 here, and so you have concentration of Ba2 positive is 0.050 and concentration of OH minus is 0.1. By use the formula H3O positive OH minus is equal to 1 times 10 power of negative 14, which is this a constant of Kw. By making H3O positive equal to 1 times 10 power of negative 14 divided by OH negative. So we substitute of OH negative. Here is that this take from here, substitute in OH minus is 0.1. So we got the answer H3O positive is equal to 1 times 10 power of negative 13. That's all for the explanation of question 4. Thank you.